Good morning, guys. Last lecture we have seen the numerical on shaft in parallel. Today we will see the numerical on shaft in series in torsion. Okay. See here, one compound shaft is given. Okay. The two shafts made by steel and aluminium. Okay. The aluminium shaft having the diameter 40 mm and length is given 600 mm and torque is at in the anti-clockwise direction and second shaft is compound shaft is connected to the aluminium shaft. See here the torque is at in anti-clockwise direction. This value is given 2t. Okay, this shaft is made by the steel and diameter of the shaft is given 50 mm and length is at 900 mm. I have segregated these two value for the shaft, the steel shaft and for the aluminium shaft. Check that length of the shaft is equal to 900 mm, then diameter of the steel shaft is equal to 50 mm. GST, this value is given. What is the G? Yes, modulus of rigidity. This value is given in GPa. You have to convert it to the MPa. Then how to convert this into MPa? 83 into 10 raised to 3 MPa. Am I right? Yes, 10 raised to 3 MPa. We know the relation. Similar way, the shear stress are induced in the steel shaft is given 83 MPa and theta is given 6 degree. Then see for the aluminium shaft, again length is given 600 mm, diameter is given 40 mm and G aluminium is given 28 GPa. We want to convert into the MPa. Then how to convert? 28 into 10 raised to 3 MPa. Okay, and there is a shear stress is induced in the aluminium shaft is given 55 MPa. Then theta is equal to 6 degree. Then we want to convert this value into the radian. You know the relation between degree and radian. Already we have seen. If you have given the 6 degree, then how to convert it into the radian? Yes, correct. Pi by 180. Multiply by pi by 180. Then you will get 0.1047 radian. Okay, guys, remember that if you have given theta is in degree, then you should convert into the radian. Then you will get the 0.1047 radian. Then what we want to calculate? We want to calculate the torque induced, maximum torque induced the given shaft. Okay, aluminium shaft, steel shaft, as well as when you add the couple, or we can say the torque in anti-clockwise direction on the steel as well as aluminium shaft, then how much torque is induced? Okay, we want to choose the safe value. Okay, all of you getting what is given in this numerical? Okay, then we will solve. How to solve this numerical? We want to calculate the torque. There you get the three torque. First is a torque based on the steel shaft. Second is a torque based on the aluminium shaft. And third is a torque based on the what? Theta. What is the theta? Angle of twist. Torque based on the angle of twist. Then out of that three value, once you have got, you have to choose the safe value. Which value will set? Minimum value will be set, or we can say the least value will be set. Okay, then we will try to solve first. See, we know the generalized formula, torsion formula. T by J is equal to G theta by L is equal to tau by R. Okay, first we require which relation to calculate the torque based on the steel. Suppose torque based on the steel, we'll write here torque based on steel. Then how to calculate that torque based on the steel? T by J is equal to tau by R. I will use this relation. Okay, and you will get the torque here, torque for the steel. Similar way, if we are using second condition, torque based on the what? Torque based on the what? Aluminium. Aluminium. Again, you will get the here in the second. We want to use the same formula, and you will get the torque for the aluminium. You know the for the compound shaft or series shaft. What is the value of theta? How to calculate the theta? Okay, how to calculate the theta? Angle of twist in the given shaft is equal to angle of twist in the steel shaft plus angle of twist in the aluminium shaft. Okay, we know this relation T by J is equal to G theta by L. Then you can convert it to the theta. If you have converted into the theta, then see what we will get. TL divided by what? TL divided by what? G into J for the steel, plus similar way TL divided by G into J for the aluminium. In this way you will get the 3 torque. You will get the 3 torque. Okay. With the help of that you can calculate the 3 torque. Okay. What is the, then see which value will require in this formula. Which value will get? We know the radius because diameter is given for each. That's why we can calculate the radius. This tau value is given. We want to calculate the J value and we want to calculate the T value. Then how to calculate that 2 value? Yes, anybody? See, I will draw the FBT for that. We know the sign convention already we have seen, right? Can you tell me the sign convention? Can I do it? Yes. All of you getting how to solve the given numerical? Yes, very good. Then see, we want to calculate. Here is a torque is applied, positive torque. Here is the anti-clockwise. See, there are 2 shafts. I will draw this 2 shafts first. First, I will clear this. We have seen the sign convention. This is for steel and this is for aluminium. There are 2 shafts. See, here is the anti-clockwise direction means downward direction. For equilibrium, here is a upward direction, force is applied or torque is applied. Again see the first shaft, here is a 2T is applied, here is a T is there and here is again anti-clockwise, left right side of that. Because of due to equilibrium, we are applying the upward direction torque. Here is a 2T is there. Then first we want to calculate, what we want to calculate? First we want to calculate aluminium shaft torque. Okay, how much torque is applied on the aluminium shaft? Here is a T shaft is applied. T torque is applied. Similar way, steel shaft torque. How much torque is applied on that steel shaft? Check that. Here is a positive, T is positive. Here is also we will consider this sign convention we have seen. This also positive. If the left side upward direction torque is applied and right side downward direction torque is applied, then we will consider the positive. Means total torque is applied on the steel. We will get T plus what? 2T. There is a 3T. We have seen the equations. We have seen the relations. Right? Here is a 3T torque is applied. Total torque is applied 3T. Because both are positive. Total torque here you will get the 3T. Okay, all of you getting how to calculate this value? Once you will get this value, then we will find out the JST value. Okay, JST. What is the JST? Polar moment of inertia. Polar moment of inertia for steel and aluminium. Okay, both material we want to calculate the polar moment of inertia. How to calculate that polar moment of inertia? Yes, anybody tell me the formula for steel as well as aluminium? polar moment of inertia is equal to pi by 64 into d raised to 4. This is the generalized formula. Okay, we put the value pi by 64 into d raised to 4 is there. What is the diameter of the steel? 50 raised to 4 is there. 50 raised to 4 is there. Then you have to check how much value will get. 613, I will write here, 613.592 into 10 raised to 3 is there. What is the unit? mm raised to 4. mm raised to 4. This is the value of JST. Similar way, we want to calculate the value of J aluminium, polar moment of inertia for aluminium shaft. How to calculate again? Pi by 64 into aluminium shaft diameter is given 40 raised to 4. Then you will get, we'll check this value, 251.327 into 10 raised to 3. What is the unit? mm raised to 4. Once you have calculated these two values, then directly there is a first step. We'll calculate torque based on first torque based on which? Torque based on the steel, torque based on the shear stress on steel shaft. Okay, torque based on the shear stress in steel shaft. Okay, shear stress in steel shaft. First we want to calculate torque based on the shear stress in steel shaft. We know the formula, T by J is equal to tau by R is there. Tau by R is there. What we want to calculate? We want to calculate the torque. Then I will write T is equal to J by R into tau is there. We know the formula. Okay, what is the J by R? Again tell me, what is the J by R? J by R is nothing but the polar sectional modulus. Okay, it is denoted by the ZP. T is equal to ZP into tau. Okay, this is the generalized formula. Already we have seen unit number 3 also in the torque theory. Okay, torsion theory. T is equal to, I will write torque in steel, TST is equal to ZP for the steel into tau ST. Okay, what is the value of ZP? You know the relation. We have calculated that relation. Yes, anybody tell me that relations? Yes. Do you know that relation T is equal to ZP into tau is there? ZP into tau is there. Then I will put the value. What is the T for the steel? There is a 3T. We don't know the value. 3T. Okay, here we will get the 3T. Then what is the ZP? ZP for the steel is pi by 16 into DST. Cube is there. Okay. And what is the tau ST as it is? You will get this formula. What is the ZP? Or individually you can also write what is the value of J and what is the value of R. Directly you will get the ZP value because both value is known. We have this value J, ST, R is equal to what for the steel? Check that 50 by 2 is there. You will get the same answer. Don't confuse. Okay, take I will put the value pi by 16 into what is the value of DST? 50 cube is there into tau ST. Tau ST is given 83 MPa. Okay. Then if you have solved this, then you will get the torque based on the steel. Torque based on the steel TST is equal to this value 679.042 into 10 raised to 3 is there. This value will get in Newton mm. Getting Newton mm because all the value we have considered in mm. That's why you will get the unit also Newton mm. Similar way, second torque based on what? Torque based on shear stress in what? Aluminium. In aluminium. What is the formula? Again, we have generalized this formula. I will write here T aluminium is equal to Zp aluminium into tau aluminium. Then you have to put the value of this. This T aluminium we have seen. What is the value of this? T is there. T is there. Only T is there. Okay. What is the Zp aluminium? Again pi by 16 into D aluminium. D aluminium cube is there into 40 cube is there. What is the tau aluminium? 55 is there. If you have calculated this value, then check that how much value you will get. Tau aluminium is equal to T aluminium is equal to, you will get torque based on the shear stress 691.15 into 10 raised to 3. This value again you will get the Newton mm. Okay. And third condition is a torque based on angle of twist. Torque based on angle of twist. Okay. How much angle of twist is given? Theta is equal to 6 degree. But we have converted into the radian. Theta is equal to 0.1047. Okay. Then we know that when the shaft is given in series, then we know theta is equal to theta St plus theta aluminium. Theta aluminium. Then you have to put the value of that. We know the generalized equation. I have solved this TL by, can I write there? TL by what? Gj or St plus TL by Gj for what? Aluminium. Okay. We are putting all this value in the equation, in the given equation. Okay. Check that. This theta we will put. Theta is equal to, what is the value of theta? Theta is equal to, we have calculated 0.1047 radian is equal to, what is the TST? Okay, TST, 3T is there, 3T into, what is the ST 900? What is the G? G is given for the steel. Check that, 83 into 10 raised to 3. What? Check that. What is the value of JST? We have calculated 613 na? 613.529 na? Into 10 raised to 3 is there. Check that. This value already we have calculated. 92 is there. Check that. Then plus, what is the T? As it is T. Okay, we don't know this value. T is equal to, we don't know. What is the length of the aluminium rod? Shaft 600 divided by, what is the G for the, J aluminium, 28 into 10 raised to 3. What is the value of J? What is the value of, tell me the value of the J for the aluminium. Yes, anybody? 251, yes. 251 point, what is the point? 327 into 10 raised to 3 is there. Okay, check all the value we have put in this equation. Then only constant is a T is there. T is there. If you have solved this, then you will get the T is equal to, I will delete this one. Check that. We will get the T is equal to 679. T is equal to 679.04 into 10 raised to 3. This is Newton mm. This value will get torque based on the angle of twist. Then how to calculate the safety? Okay, when we get the shape T, you have to choose the least value out of that this three value. Which is the least value? Check that. Tau st is T is equal to, we have got here same value I have written. T is equal to, check that, 757.204 into 10 raised to 3. This is in Newton mm. Okay, this three value we have. Check that. In the first step, we have the tau value is equal to 691. Then second value we have this is the second value, this is the first value 679.042, and this is the third value 757. Which is the least value? Yes, first one. Yes, 679.042. This is your answer. Write the shape torque. When we get the shape torque is equal to shape torque in steel, we'll get this one 679.042. What happens when you add the torque? T is equal to 757. This torque will be bent or this torque will be filled. Okay, that's why choose the minimum value. Choose the minimum value, least value. We want to calculate the shape value. If we are asking this minimum value on this aluminum shaft as well as here this value on the steel shaft, this will be safe. This will not bend. That's why you have to choose the minimum value. Today we will stop here. Next lecture we will see one more numerical and we'll see the remaining part in the next lecture. Thank you.